Hello, I just wanted to make a quick video going over Gaussian elimination. Sorry, let me wait for this plane to pass. So I just wanted to make this quick video going over Gaussian elimination because it's a very important component of the test that is coming up. So you're going to get a point that's 20, so you're going to get a question that's 20 points. And that's going to be one of these questions about solving a system of equations using Gaussian elimination, Gauss-Jordan elimination specifically, to get a reduced row echelon form. And so that's going to be 20 points. But another 20-point question is also the question about finding an inverse matrix of a 3x3 matrix. That requires using Gauss-Jordan elimination as well. So 40 points on the test are about essentially just Gauss-Jordan elimination. So it behooves us to be able to do this well. So here's the general procedure that I wanted to go over. The first step is always to get rid of these two numbers using row 1. Okay. The second step is always getting rid of this number using row 2. Then you'll be in row echelon form. Okay, and then the third step is to get rid of these two numbers using row 3. And then the fourth and final step is to get rid of this number using row 2. Okay, and so once you do all that, you'll be left with only numbers in the diagonal spots, and then you can do the final step of dividing so that those become ones. Okay, so your first step is always to try to get those zeros in this order. Okay, in this order to get those to be zeros, and then and only after that do you want to turn those diagonal elements into ones. Okay, if you turn them into 1 too early, then you're going to probably run into a lot of fractions, which are not very helpful for your cancellation process. Okay, so I'll go over with this example. So I've written it as an augmented matrix already. And so my first step is to try to get rid of these two elements using the top left number. Okay, and so I'm going to do that by replacing rows 2 and 3 with 3r1 plus r2 and 3r1 plus r3. Okay, the reason is because 3r1 is going to give me a negative 3 here, which will cancel out with my 3's once I add them to rows 2 and 3. Okay, so after I do that, my first row stays the same. Sorry, it's a bit windy. Hopefully it's not bothering anybody. Okay, then you'll get 0 here. That's negative 3 plus 3. And then this element here is negative 18 minus 5, which is minus 23, and so on. The third row is 0, and minus 18 plus 5, negative 13, and then negative 3 plus 4, 1, negative 33 plus 1 is negative 32. Okay. The next step, as I said before, is to get rid of this one specifically using row 2. And at this juncture, it's very important that you choose the right row to eliminate that number with. Because if you had tried to eliminate it with row 1, then this would have introduced a number into that 0 spot, right? And so that's why we have to use row 2 in order to eliminate that number there. That's a little tricky because you have to multiply things to get them to be the same and cancel out. So what I'm going to do is multiply the second row by 13 and the bottom row by negative 23. And as you can see, if I do that, then they'll cancel after adding. So that does require some multiplication. I don't know that off the top of my head. They're going to cancel anyways, but I'm just going to write them out. 299. Okay, and then negative 6 times 13 is 78. Negative 78 and minus 130. And the bottom becomes 0, 299, negative 23, and I don't know what that is. finally, you can add rows 2 and 3, and then that'll successfully cancel out that negative 13 there on the bottom. You can also revert row 2 back to what it was previously. And I'm left with 606 here. Okay? So at this point, I am almost in row echelon form, with the exception of those diagonal elements not being ones, but rather some number other than 1. But I have all the zeros in the right place. Okay, so now at this step, what you could do is go to row echelon form and make those turn into 1s, but the problem is that would introduce some fractions. And we generally want to avoid that, so at this point, we want to simplify as much as possible to make the numbers as small as possible without introducing fractions. That's generally a good step. So I'm going to keep the first row the same. And the second row, I'm also going to keep the same because I can't really divide by a common factor to make those numbers smaller. But the third row, I can simplify that quite a bit. The reason is because, sorry, that's not 110, it's 101. The reason is because they both share a common factor of 101, right? And so I can divide by 101 or negative 101, and I'm going to be left with 1 and negative 6. Okay, so I just want to simplify as much as possible without introducing fractions. Okay, so the next step in Gauss-Jordan elimination is to turn these both into zeros by using the third row. And it's very important, you have to be using the third row, otherwise you're going to ruin some of these zeros here. Okay, so what I'm going to do is replace row 2 using R2 plus 6R3, okay? And I want to be replacing row 2 because that's where I want the zeros, right? So just think, wherever you want the zeros, that's where you're going to be replacing the row, okay? And then row 1, you can simply replace with R1 plus R3, and that's going to give you a 0 there, in that spot right there, right? So what are we going to be left with? R1 plus R3 is the first step. We're going to be left with minus 1, minus 6, and then negative 1 plus 1 is 0, as desired. And the final number is going to be negative 17. Then this one becomes negative 23, and then R2 plus 6R3, right? So this is going to be a 0. And then negative 10 minus 36 is negative 46. Okay? Okay, and then the next step, I'm noticing that this is a good place to simplify some things, right? Because 23 and 46, well, 46 is just a multiple of 26, right? And so that's super easy to simplify. I can just make that turn into negative 1, negative 6, 0, negative 17, 0, 1, 0, 2, because 46 is 2 times 23. And so that's what I'm left with. Okay, and then I'm almost done. What I need to do now is get rid of this minus 6 using the 1 here, right? That's the very final step of Gauss-Jordan elimination. And I'm going to do that by replacing row 1 with R1 plus 6R2, okay, right? Because if I turn this into a 6, then that's going to cancel with the minus 6, right? So I'm going to be left with negative 1, 0, 0, and then negative 17 plus 12, which is negative 5. 0, 1, 0, 2, 0, 0, 1, minus 6. Okay, and my very final step is to get all of these diagonal elements to be 1s. And so I just need to change the sign of the top row, and I'm done. 1, 0, 0, 5, 0, 1, 0, 2, and 0, 0, 1, negative 6. So my answer is 5, 2, negative 6. Okay, so just to recap this entire process, some important tips. Make sure you do the row eliminations in the right order. That's the first important tip. You have to start with these two by eliminating with the first row. And then you do this one by eliminating with the second row. And then you do this one by eliminating with the third row, this one with the third row, and then this one finally with the second row. Okay. A second important tip is to only simplify rows when they conveniently simplify into something that looks nice, that's easier to manipulate. So for example, when we had -101 and 606, that's something we should clearly simplify to 1 and -6. Okay, or for example, when we had 23 and 46, we should clearly simplify that to 1 and 2. But that also means that we should save the final division for the very last step in order to get those into ones, right? Because if we had tried to convert these diagonal elements into ones at such an early step, that would have introduced a lot of fractions, right? Because this would have turned into 6/23, and this would have become 10/23. And that's really unnecessary for our purposes, because we only need it to be ones at the very last step. So that's something you should save for the end, unless it saves you time, such as in this case, where 23 and 46 can change into 1 and 2. That saves you a lot of time, because then you don't have to deal with such big numbers. But if it doesn't save you any time, then don't do it until the final step, because that's the only step where we really care about those actually being ones. Finally, remember some other row operations that might be useful include actually switching the rows. So there are some instances where that might be helpful. To get something in the right place, you might want to switch to different rows, and that's something that's perfectly allowed. Hopefully this video is helpful, and good luck on the test.